Thanks for coming, everyone. My name is John Rodriguez, and I work on Cash App at Block. And today I'm going to be talking about Paparazzi and Snapshot testing. If you're familiar with Cash App, if you use the app, you'd maybe realize that we offer the ability to enable payments for merchants, enabling consumers to manage their money through financial services like banking, lending, investing in Bitcoin. And when we started growing the team, I want to say around 3 years ago, from a handful of Android engineers to a much bigger team, we realized that we needed new tooling to scale for that need, especially with, as we started to grow engineering, we also started to grow our design team, and we were both pushing each other to basically come up with the best app that we could. So back in 2019, after a short hack week, we released an early version of Paparazzi, and the idea was to help accelerate Android UI development. Now, I've given this talk before, and I've trimmed a bit out of the intro, because I'm going to assume at this point someone's at least heard of Paparazzi, if not using it in your repos, which is great. But there will be also, for those who maybe are seeing it for the first time, a quick intro of like what's the premise and what it looks like. So just a heads up if you've seen the talk before. So with this growth, we're excited to hear that not only everyone on our team has been using it on their day-to-day, especially now that with Compose support and a few performance speedups, but also people at Google and Twitter, Dropbox, Facebook, the Android X team and Wear team at Google have started adoption of Paparazzi. And so the project's getting a lot more popular. And so part of the talk that I want to give today is really how to enable contributors to work in Paparazzi. It's an interesting project. There's a lot of moving parts, something that it's challenging me every time I contribute to it, and hopefully you'll get a better understanding of the internals after this talk. So like I said, if this is your first time hearing about it, if you've never used it, the premise is to tighten the feedback loop between engineering and design. So you've been assigned to work on the next hot feature, you get a Figma spec from your designers, and you either use a legacy Android layout, or now you're working in Compose and you play with the preview section. Either way, sometimes you go from what seems like a relatively simple layout preview to something that quickly looks like this, because maybe you're embedding business logic. Maybe there's just something with a bug in layout preview. And even once you get that to work, you have to build the app and put it on your device and your emulator. That takes time, because you have to then use Gradle, probably, and build your app and deploy the APK. The Android build toolchain is very complicated. There's crunching of resources. There's building the bytecode. Maybe you're using RA to do a lot of that, to shrink your app to a smaller size. Oh, did I skip? There we go. We have a lot of Gradle savants on our team, and even so, just the feedback loop of building your app, putting it on your device, we've gotten it down to a handful of minutes with incremental builds, but that's still not great for iterating on, say, a new screen. If your text view is just such a bit off, and now you have to incur another 2 to 4 minutes just to make sure that you added some margin, that can be frustrating, especially over a few cycles. Even once you get it on your device or emulator, now you have to hunt for the screen. If you use server-driven UI, then you have to go mock that out. If you have feature flags, you have to toggle on the flag so you could find that screen. So it's really just all this hassle. If staging is down and you're trying to test that, you may not even be able to get to the screen having done everything prior. So this problem is not unique to the Cache team. Everyone, Android developers of the world, face this problem. And so 3 years ago, we started hacking around by looking at how does layout preview work in Android Studio, and how can we find a way to essentially weaponize it. We started off copying the plugin jars from Android Studio into a workspace and started playing around with some of that. And by the end of the week, we got a cool proof of concept of being able to run and render a view on a JVM, not having to compile to Dex, not having to have an APK. So all the things that you may have been accustomed to using, say, Robo Electric or Espresso, you've removed much of the need for that if all you really wanted to do is get an idea of how your view renders. And yeah, it actually does take a matter of seconds. So I'm going to skip through that and just show you what does a Paparazzi test look like. Pretty simple. You instantiate the JUnit rule. and you set up whatever your viewer composable looks like, and then take it as a snapshot. Yeah, pretty much what I just said here. And as of 1.0, we do have compose support, and it works very nicely. The default mode that we want you to use is just the normal test mode, which is we call internally development mode. And the idea is that you run this as you're iterating over your view. Think of what the live preview provides in Android Studio. An alternative is to use Paparazzi to do that, and you can see your incremental progress. After you reach a state where you're satisfied, you then record Paparazzi. You run the record task, and now that's going to save the rendered view into the file system where you would probably save it using Git LFS or maybe push it to an NFS share so you can have a catalog of all the screens in your app that you've covered. And then on CI, you're probably running a verify test to make sure that you have no accidental regressions. Who here is familiar with test parameter injector? Great. Cool library. It essentially allows you to parameterize tests with either enums or value providers, such that instead of duplicating test methods from scratch, you can do things like this. Like say you wanted to test multiple device configs or multiple themes, maybe light mode and dark mode. You can set up a Paparazzi test like so, and because you have two enums with two values each, computer is slow now, great. You get the cross product of two device configs and two themes for a total of 4 renderings. This is what it looks like when you're done. And so you can maybe save that as like part of a browser. We have a Snapshot browser internally that I'll mention, but it essentially shows all the permutations your screen would look like. Come on, Keynote. So Cache App architecture, we have a lot of design patterns internally of how we architect our apps. But on a very simple level, we have a presenter and we have a UI layer abstracted away by interfaces. And they talk to each other via either view events, interactions by the user with the screen. And then the presenter will run some business logic and spit out a model which populates the screen. That's really all I'm going to talk about it, because there's a really great talk later today that you should go check out by my teammate Benoit, where he talks about how we do architecture at scale at Cache App. So if you're curious, go check it out. But going with that idea, if you subscribe to the concept of having your presenter logic and view logic separated, which why wouldn't you? It turns out it makes your Paparazzi tests even more pleasant to write. You don't have to worry about RX schedulers or coroutine flows or what have you, however you implement it. Instead, your view becomes the basic view that it really should have been to begin with. Set some values and render it. And so something like this, it looks conceivably simple. And then run a Paparazzi test where you can vary what model you're driving the UI with. And you can get even the more complicated screenshots. And this is actually a screen that's backed using filament. And Paparazzi was able to render some of those screenshots. OK, so let's peek behind the curtain of how this actually works now that we've seen a little sample of how to use it. So Paparazzi relies heavily on this library called LayoutLib. LayoutLib is what drives Layout Inspector in Android Studio. So we're going to be talking a lot about that. It relies then on the Android framework, Android.jar. However, something to know is that if you're not on a device, you don't have hardware sensors. Also, if you've done enough AOSP digging, you realize that after a while you're making native calls. And some of those things would just not work in an IDE. And so what the Android team at Google's done to create LayoutLib is they take Android.jar and introspect it in order to basically do bytecode interception of certain method calls and route it to these delegates. And I'll talk more about that in a bit. OK. So if you've been doing Android for a while, Layout Preview has been around since API 5, when Eclipse was the IDE of choice, and you were maybe using the Maven Android plugin. Even though today we're using IntelliJ, which is the base for Android Studio, and Gradle probably by default, Layout Inspector is still present. So core to LayoutLib is this class called Bridge. Bridge is passed a series of parameters, basically file paths, where it'll find your build properties, where your fonts are located, calendar data, and along with some shared libraries, which I'll talk about in a second. But think of Bridge as the Android runtime analog. Once you have instantiated that Bridge, you're going to set up session parameters. Session parameters are going to have your content route. You're going to give it a rendering mode of whether you want to do horizontal or vertical scrolling. Hardware config is the equivalent of your device. Are you a Pixel 6? Are you a foldable? You specify that with your hardware config. Resources, as implied, would be all the resources in your transitive dependencies, your source main res, your source debug res. LayoutLib callback. LayoutLib needs some help to map your r.class files to the resources on the file system, and the way that it does it is by calling your callback, and Paparazzi implements that. But Android Studio as well implements it to implement Layout Inspector. And then, of course, the min SDK, target SDK, since you could have different rendering behaviors according to those two things. Once you pass that, and one thing to mention is now the session params are the analog to your app. And so now that you pass this analog of your app to the analog of the Android runtime, you will get something called a session. Now you pass your viewer composable to that session and take a snapshot. And here you go. You get a buffered image. You write it to the file system. This is how Android Studio works in Layout using a render task, and basically a background task so it doesn't block the IDE main thread. But Paparazzi, because it's running as a JUnit rule, has no problem blocking your test thread. What else would you be waiting for anyway? That flashed by really fast. Using the delegate pattern, you can actually set the system time clock for the choreographer, and as a result, not just take a snapshot, but do a sequence of snapshots resulting in animations video. It's not heavily supported yet. We have a few things to work out, but the functionality is there. OK, so now let's look at Bridge. Bridge, as I mentioned, relies on a session. And while we're not going to dig through all this code, the main things to point out is it comes out with some concept, it fakes out some concept of context and inflator. In an APK, you would have an inflator that parses binary resources. You'd have a context that has your environment to Android. It has to act very differently in the IDE or in a unit test. And so you can see like resources, context, and layout inflator all have to kind of be wired together by Bridge in order to mock out how an Android runtime would act for your app. And this talks about that. Basically, if you unzip an APK and you look at the binary, if you look at your layout files, you'll see that they would actually be packaged as binary. How is that rendering? Is it janky? Yeah. And you can detect some of the attributes there, but LayoutLib wouldn't have to do this. It goes directly to your directories. So we can bypass APT and a lot of the compilation that you would normally have to do to build an APK, which is why you get the speed up difference. To create this delegate pattern, LayoutLib has the DSL that essentially says which methods they want to intercept using this create tool. So to give a quick example, let's say you're looking up a drawable via the resources API. What LayoutLib will do is rewrite that methods get drawable method to call it essentially original, and replace it with its own getDrawable. And so there are times where LayoutLib will actually still use the true code path, and other times it'll intercept and do something completely different than what would happen in your device. And sometimes that can result in bugs, which we'll talk about. If we look inside LayoutLib jar, we see that they rely heavily on the delegate pattern. And sometimes they relied on it a bit too much. At some point, even font rendering was handled differently, because if you've gone into text view and see how font rendering works, there are native calls there as well. And LayoutLib used to be a pure JVM dependency. It got a little frustrating, though, for supporting things like line spacing, line height. It just wasn't quite pixel perfect. And so I think just before Android Studio Arctic Fox came out, the Android team decided to move from a pure JVM implementation to using a JNI bootstrap to run the exact same Skia graphics pipeline that the Android runtime on devices use. And so that resulted in a bit more clarity. Here's an example of that. If you can't tell the difference, and I don't blame you, between these two views, but did that? How about now? And so you can see that now, you can see that spacing takes into account here because it's using the true Skia pipeline, whereas before using Java AWT toolkit actually had surfaced quite a few bugs. It turns out if you use the Oracle JDK or .jdk different versions, things like ascenders and letting embedded into the font would not necessarily be interpreted correctly. All right, so now let's look at more into Paparazzi itself. It aims to be as configurable as possible to test your app, while at the same time providing reasonable defaults if you just want to run. Things like the snapshot handler is essentially, in every single case, you're going to take a snapshot. How are you going to handle it? Are you going to write it to a web page? Are you going to, I'm skipping here, it's a bit annoying. Are you going to write it to an HTML report? Are you going to save it to disk? Or are you going to purely verify? Either way, you're taking a rendering of something. OK, so how do you detect your environment? Well, in order to help drive LayoutLib, it has to know where your platform's directory is. It has to know where the resources are located. And so how does it drive that? Well, the IDE knows where that is because it can infer from Android Home or Java Home where all your system dependencies are. But in LayoutLib, you also would need the help of the Gradle plugin. And so if you're familiar with how roboelectric properties used to work, you had to specify essentially a text file that told roboelectric where to find all those platform dependencies. We chose instead to write a Gradle plugin to just configure that for you. And so there's a task called the Prepare Paparazzi Resources task that will infer using the Android Gradle plugin where these paths live and write it to a file and hooks itself in between the Android Gradle plugins tasks. So for merging resources, it needs to know where the output of that will be, and also for compilation. Similarly, it does so for assets. At the result of this, it knows that after all resources are merged from transitive dependencies, it'll be located in the build intermediates jar. And so that file that's written to disk will contain that path so that later on Paparazzi can consume it. Now, one thing to note there is we pass it to Paparazzi as a system property. And we do that intentionally because even though we use the Gradle plugin on Cash App, and you may do it as well, other companies may have different build systems, Bazel or what like. And so we wanted to make sure that Gradle's dependencies didn't leak into the JUnit role, but rather just draw the bits necessary via the Gradle plugin for those who wanted to consume it. So now instead of depending on the test library like so, if you use the plugin, you'd update your build script, or you'd use the plugin's notation and instead apply it. So I mentioned the Android runtime, and right now, we're still using the same mechanism that we used during Hack Week. At the moment, LayoutLib is built using Google's Bazel build scripts. We wanted to bypass that and just get up and running quickly. And so it turns out that LayoutLib is already pre-built. The binary exists in the Google repo as well, and so we depend on that. We're not building it from source, which means, unfortunately, if you download it, we also have no source files to debug easily with, nor JavaDoc. Lately, in conversation with the Android X team, they're really interested in having the ability to debug and contribute as well. And so the Android Studio team may be publishing LayoutLib themselves, whereas right now it's an internal dependency that we kind of pluck out of AOSP, and so that would save us a lot of trouble. In the meantime, though, because it hasn't yet been deployed to Maven Central or Maven Google, what we wind up having to do is we have to clone the pre-built, and this is where I mentioned the Google issue. where please, if you're interested in developing on Paparazzi, +1 that issue. But in the meantime, what we're doing with, for deployment strategy is we clone the pre-built directory, and then we repackage both the native JDK11, that's the bootstrap. That's a pure JVM library that then has to, depending on your platform, load a bunch of shared libraries. And so right now, LayoutLib is supported on 4 platforms, Linux, Windows, and both Mac Intel and Mac ARM. And so we have to also deploy the appropriate platform-specific stuff so that Paparazzi can find it. And so if you take a look there, come on, Keynote. And there it is. However, deploying this to Maven Central, you deploy jars and AARs to Maven Central. And then one thing you'll notice is when you're interacting with Bridge is that Bridge wants paths to files or directories, not paths to jars. And so we had to be a little clever there because when you install Android Studio, you actually install a build of Android Studio that's specific to your platform. Your build for Android Studio on Mac ARM will not be the same as Mac Intel. And so when you're installing Android Studio, the corresponding LayoutLib libraries are already exploded onto the file system and put in the right places so that Bridge knows, it basically hard codes the paths of where to look. Since we're deploying all of this to Maven Central, we can't just do that because Maven Central doesn't allow us to. However, we can use Gradle again. It turns out if you look at the documentation for artifact transforms, something similar to how Jetafire works, right? Remember you're moving from support lib to the new jam, you had to update all your packages, and that was annoying because you had them all over the place, but if you ran Jetafire, it did it for you. It looked at all your XML resources, it looked at your bytecode and swapped out the packages. And it did so by using an artifact transform where it took the original support lib AAR and converted all of it to a new AAR. And it turns out you can also write a transform to do unzipping. And so if you specify a configuration and you pass that AAR to that configuration and register a transform for the input type of that configuration, it'll not only fetch the dependency from Maven Central, but also expand it in a different place in your Gradle cache. And then you can point those paths to Bridge. It's also nice and cacheable because otherwise, imagine if you were using Paparazzi in different repos or in different projects, if at runtime you had to unzip a jar, it would add a bit of performance penalty to running your tests. This bypasses that, and once you download a version of Paparazzi on your file system, it's available to all projects for that version. And that just explains what I said. There we go. Cool. So I mentioned Gradle support. A common question asked is, what about Bazel support? In a previous talk, I said, well, contributions are welcome, but we're in talks right now with Uber. Is Ty in the audience? Sorry, Ty, I should have asked you if I could put your Uber logo there, but whatever. But currently, the Uber team is working on a Bazel plugin to contribute. So we're hopeful, and we're in conversations on how we can make that API seamless. Let's talk about accessibility. So Paparazzi right now has support for this in 2 ways. One, you can either scale fonts a certain way. I think actually it's an outdated way. We don't do it like that anymore, but it works. And so that's how you would be able to test like your user increasing font sizes. Again, using test parameter injector makes this a cinch. And we've also have this internal method where we scroll over the entire like lazy column or recycler view in order to render something like this. That's great. Thank you. Please hold a little applause to the end. We wanted to also make this a bit generic because while we can think of accessibility use cases at the moment, really it's just layering, taking in a view and adding some view hierarchy, some extra metadata. And so, yes, we're using for accessibility, but maybe there's a use case out there for you. So we're happy to hear what other ideas you might have, if any. And yeah, that's basically how it works. It takes the regular image that it would have gotten already and wraps it in a nice interceptor chain style. And yeah, so when that PR came out, it was very exciting. We started to use it a bit in Cash App, and it's already caught some errors in our app accordingly, like good tests should do. Tell your iOS developers that we also have an iOS library for accessibility snapshots in case they're interested. And this is how it looks. It color codes a view hierarchy, and then the legend shows if you are missing a content description, or maybe if your view hierarchy is intercepting events. To implement, take your normal Paparazzi test and simply add that render extension, and that's it. One thing to know about Paparazzi is that LayoutLib bugs become your bugs, and so if you see that Layout Inspector is acting a certain way, Paparazzi will too, because it depends heavily on that core. For example, when there was some work done on cache card renderings, we had a bug like this. After scratching our heads for a while and figuring out what the root cause was, what we found out is that there was a missing, I mentioned earlier how Paparazzi, or rather LayoutLib, relies heavily on delegates. Sometimes the delegates are no-ops. They just haven't implemented it yet because there wasn't a need to in Layout Inspector. Ideally, we'll start contributing upstream to LayoutLib and helping the Google team fix this, but we basically took a page out of Roboelectric Shadows or Marketo Spies and introduced our own bytecode manipulation. We hope not to double down on that too much because of all the problems that tend to happen when you resort to that, but it has proved handy in some cases. In the case that we're mentioning, the reason the card wasn't rendering is because matrix operations tend to be native calls, and the multiply operation wasn't implemented. So we just copied some code from how Roboelectric Shadows does it, and we've also used font renderings for things like Android X fonts. So Android X is not part of the Android runtime. It's an external library. And so intercepting calls on Android X, Paparazzi would not have a delegate matching for that. And so sometimes we've had to kind of tell Android X to actually look here for something using the interceptor method. Also, things like view and edit mode, if you were using that in legacy views, we disable that for Paparazzi because we actually want to render the view as it was on device, not that workaround for Android Studio. Let's talk a little bit about Jetpack Compose. When we implemented it for 1.0, we found that it really kind of predicated itself on working with Choreographer. Choreographer itself is delegated, so things like handling the handler thread and all the callbacks that you post to it have to be orchestrated by Paparazzi and Layout Inspector. One of the things that we love about Compose on Cash App is using the preview method. And so one of the things that a teammate has been working on and has been highly requested on Twitter is the ability to come up with a Paparazzi annotation, thereby reusing your previews and auto-generating the snapshot tests. It hasn't hit master yet because we're trying to figure out the right API. Some previews are meant to just be simple tests, and maybe some of your unit tests will be more complicated than that. But it's coming soon. There's a teammate who's been putting a lot of time into it, and it's really starting to shape up nicely. And let's talk about resources. So even though in the Compose world you will not be using layout resources much, you will still probably be using other types of resources. And right now, r.class, if you have the default global r.class set up, all your transitive resources are bundled into one r class. However, if you enable not this little property on Gradle, you'll get namespacing, which means it increases the number of r classes in your project. So why do I mention this? So Paparazzi, the way that Paparazzi works, it first has to load all the r classes so that it can find those integer indexes, while at the same time crawling your source in all that build intermediates merge resource directory to actually find the resource and map that up so that when Paparazzi's executing your code and looking for r.drawable.whatever, it knows how to first map that into a resource reference and then find it on the file system. There is a problem with this at the moment in that, again, one of the original Hack Week ideas was, how do we get this up and running fast? There was a handy class called Resource Repository, and we knew it was deprecated when we started working on this, but it was so tempting to just have something that you pass a file directory, and it loaded all the resources into a multi-map for you. Otherwise, you'd have to implement it yourself. And so we went with it. And we're still on it. When we realized that that directory had to be a single directory and not a set of directories, and we realized that we were pointing to source main res, and we were not pulling in, say, the Robinhood Spark graphing libraries resources, because that's in an AAR. Our workaround for that was, let's not use source main res anymore. Let's instead use that build intermediate merge debug folder, which came about by digging into Android Gradle plugin internals. And it's worked very well for a while, but it's not great. What we really want to do is use the original res folders. Why? Well, first, we're peeking into Android Gradle plugin internals. That can change at any time. Secondly, if you look inside library modules versus app modules, the merged resources for an app module are converted to protocol buffer. And so you may notice that Paparazzi right now is not supported in app modules, only library modules. This is why. And so it behooves us to stop looking in the build intermediates folder and instead look back at the source main or source debug reses so that we can get functionality back for that. Another con to using the deprecated resource repository is there are just some bugs in that implementation that have been completely overhauled and implemented correctly. Like, for example, if you've used Paparazzi with HTML strings, the tags will be ignored, and it turns out after the first closing tag, you will just drop the rest of the string. And so that's not great, and it's a long-standing issue that we've had to work around. Unfortunately, so the TLDR is we're rewriting how resources are loaded in Paparazzi, but that's not a trivial task. And so working with Paparazzi tends to also be interested in looking at the source code for Layout Inspector and seeing how it does it, and then essentially cribbing some of that in some way. In this case, it's a little more complicated because the way that Layout Inspector discovers all the resources is by using the IntelliJ PSI model, which is great if you're writing something in an IDE, which is what Layout Inspector runs in. But Paparazzi could also run on the command line, and running PSI would essentially pull a bunch of the IDE bits along with it. And so that's the problem that we're having at the moment, and what we need to solve is that instead of using the PSI model, can we instead maybe use more Gradle bits, but instead to find out at the very least the dependency graph of where these resources live, and then still deal with their original resource source folders. There's an issue there if you want to track it. Maybe I've nerd sniped you to maybe help contribute to the solution, but if not, it'll be coming soon. Another thing that we're looking into is right now Paparazzi is by design a JUnit rule, and that's it. But we believe there's a potential to have so much more. What if we can extract the Paparazzi core out of JUnit? Sure, it'll have a JUnit lifecycle, it'll have a setup and a teardown. But what if we can use it as a rendering engine, and what use might that have? So for example, you may have seen Jake and Jesse's talk about Treehouse or Zipline or Redwood and what the future holds for us. But in the meantime, we have many flows that have identical forms, and we call it internally form blocker. Think of it as like an HTML DOM that you assemble from multiple elements, because if you look at different flows, they have some similarity. Like here you have an icon, a title, some description text, and then a primary button with an action. Very templatized. Well, when our server engineers want to currently test whether this works, it's either, hey, client engineer, help us out and see how this renders. We've developed some tooling where we can drag and drop from a web page into a form and then hook into an emulator that's running KTOR. But that's annoying because now your server engineer or your designer, who may also be interested to see how this looks on device, has to install the entire Android toolchain, like ADB, emulators. Why? Like, I just want to see it render. And so we wonder whether we can use Paparazzi for something like this, not as a snapshot tester, but just as a kind of mock renderer in real time. And so during a hack week this year, someone's already started. We wanted to try to, instead of making it a web page, make it a Jetpack composed desktop app, which hooks into this soon-to-come Paparazzi core. And then similar to the web page, drag and drop your elements and get a real-time rendering without the need for a device. This will probably not be open source because, as I mentioned, form blocker is an internal cache app thing. But if you see a compelling use case that I haven't covered thus far, please share with us. We're happy to hack on this together. And yeah, this is what we have so far. Again, it's just really just learning how to do desktop nav on Jetpack Compose, but it's promising. And that's it. If you have any questions, I'm happy to take them off the side after this stage. And if you have any compelling use cases or want to contribute, please contribute on the GitHub discussions or file an issue or just tweet at me at jrodbx at Twitter. Thank you very much.